Hey, grade 12. So I was asked to do a quick explanation of page 1, question number 9. And in question 9 on page 1, it says that we've got 10 liters of saturated magnesium carbonate evaporated and 0.12 grams of solid magnesium carbonate obtained. So find the KSP. Well, we know we're dealing with magnesium carbonate, so I can do the big 3 steps. And I'm going to be looking for the KSP. That means somewhere along the line they must have given me X, but nowhere in here do I see moles per liter. I do, however, see grams and 10 liters. So what we're seeing is a situation where I have a container, and this container is full of a magnesium carbonate solution. So we've got magnesium carbonate here, and this solution is aqueous and it is saturated, which means it's holding as much as it can. So this total amount is 10 liters. And when I evaporate all of the water, all I'm going to have left is a little pile of salt at the bottom, and that little pile of salt is going to have 0.12 grams of magnesium carbonate remaining. So I know that there was 0.12 grams of magnesium carbonate in a total of 10 liters of solution. And I know that every 1 mole of magnesium carbonate, if I add up a magnesium, a carbon, and 3 oxygens, their masses off the periodic table, weighs 84.3 grams. So we now have a factor label. Grams on the top cancels grams on the bottom, and we're going to be left with moles over liter. So 0.12 divided by 10 divided by 84.3, we're going to get 1.42 times 10 to the power of -4. Okay, that's how much we're going to have in moles per liter. So that was the concentration of this when it was saturated. And since that was the concentration saturated, that was the most that it could hold. That was its solubility. This value is X. So if we go now to the solubility, the big 3 steps for magnesium carbonate, and we say that magnesium carbonate will break down at equilibrium to give you magnesium plus 2 ion and carbonate minus 2 ion. This is a balanced equation. There's 1 magnesium and 1 carbonate on either side. Plus 2 and minus 2 is an overall charge of 0 here and an overall charge of 0 here. So this is balanced. So the molar ratio then is X to X to X. And my KSP expression is going to be the concentration of the magnesium plus 2 ion times the concentration of the carbonate ion. This right here is the money step. If I ever ask you for a KSP expression, this is what I'm looking for. And now we're going to substitute the concentration of magnesium we said was X. The concentration of carbonate here we said was X. So my very simple math expression, KSP, is equal to X times X, or X squared. So this now is my simple math expression that I can use to calculate either KSP or X. Now in this question that we were given, it says find the KSP, so I now know X. So we're going to find the KSP, and we right here calculated X as 1.42 times 10 to the minus 4. So I'm going to substitute that in place of X. So I'm going to say my KSP then is going to be 1.42 times 10 to the power of minus 4, all squared. Now again, on your calculators, in order for us to do this correctly, hopefully this is going to show clear for you guys. Okay, so we're going to go 1.42, and we're going to hit my X button. I don't want to go times 10 to the power of -4, and then I'm going to find my squared button, and I will have 2.02 times 10 to the minus 8. And that will be the value of the KSP for magnesium carbonate at equilibrium.